And now we have this is a lot, again, a new innovation for the mobile robot business. In this case, we are going to talk about sensors, cutting-edge sensors, new sensors to provide your mobile robots with new features and with more advanced capabilities. And I'm very happy to have here Maria Degmair from Toposens that is going to show us what are these 3D ultrasonic sensors and how do they improve their mobile robot behavior. So please, Maria, go ahead, explain us who you are and what you are doing, and feel free to start your presentation to illustrate us.
Okay, thank you very much, Alfredo. Thank you for introducing me and Toposens. And as you said, yeah, we are a provider of a very innovative sensing solution for the mobile robot industry. Always keen to provide the industry with innovative products. And without further ado, just quickly introduce myself. I'm in charge of marketing here at Toposens, and I think we should just slide straight into the slides. So everybody, thank you for joining this webinar, and again, thank you very much, Alfredo, for having us here on this webinar. And I am going to tell you all about the ECHO ONE now, which is a 3D ultrasonic collision avoidance system for mobile robots. Now, just a little bit about the company beforehand. We are now called actually MySense, the company, but it was formerly Toposens, and everybody obviously knows Toposens as a company. So to stop any confusion, this is what our brand will continue to be. Our products will continue to be marketed under Toposens. And MySense exists since 2023, so it is just all fresh and founded this year, but obviously from Toposens, so that's why we've been going since 2015. So just close to 8 years now, still in Munich, headquartered in Munich, and have, as you can see here, over 75,000 hours of R&D combined, with over 10 patents in 6 different types. And our CEO is Alexander Rudoy, who used to be the CTO of Toposens GmbH, and he's also the inventor behind the technology. Now, going straight into it, this is it. This is our, or should we say, the world's first and only 3D ultrasonic sensor for collision avoidance in mobile robots. This is what it looks like. And now, why is there a need for that at all in the current sort of market? Now, the problem is, as we all know, and everybody working with AGVs and AMRs and anything that moves autonomously, is that there is always a risk of collisions, especially in busy factories and warehouses. And when these collisions occur, the costs can usually be very, very high. And we have a figure here. There's anything from 100K to up to 1 million per year per factory, so highlighting the need for a collision avoidance that is adequate enough to sort of get this figure down. And where we have problems mainly is with, as we know, anything that moves autonomously across the floor needs sensors to sort of sense and navigate around the path. And there are different types of sensors based on the underlying physics. And the main sensors used these days are optical sensors, such as lidars and cameras. They do have difficulties, and this is only due to the physics behind. They do have difficulties detecting when the environment conditions are not ideal, when they're unfavorable, and when the surface is of a certain structure that just makes it a little bit more difficult for these optical sensors, such as transparent surfaces, mirror surfaces, or when the lighting conditions are too bright or too dark. And as a consequence of that, there's objects such as, for example, the forklift forks that are typically black that are difficult to detect. And that, as a consequence, poses a risk of damage to AGVs or in mixed operations, also when obviously workers are around and about. Now, that in turn limits, as you can imagine, the return of investment on AGVs and HV systems as a whole. Now, this is what can happen, as you can see here, if you have a system that, I'm just going to pause this now in this video, so you can sort of get the idea of behind what I'm saying, is when you have the very important 2D safety sliders that any really well-functioning system should have anyway. They, as the word suggests, they sense on a 2D plane. So anything above or below that 2D plane does not get detected. So if we have forklift forks that are here coming in from the side on a height that is below or above the scanning plane of that 2D LiDAR, then this can happen, as you can see here. So basically, and that's just a quick video, so carry on from there. And this is where the ultrasonic sensing comes into play. Now, just quickly diving into the physics behind it. So it is based on time of flight, that combined with triangulation. And then what makes it so special is the patented algorithms that we have then in our processing unit behind it. Now, as you can see here on the bottom, that little bat, you may wonder why there is a bat, but lo and behold, it's actually quite simple and straightforward. So we all know bats fly at night in total darkness, totally unaided by anything other than their very own inbuilt sensory system. We call it echolocation. And I mean, it is known as echolocation. I'm sure you've heard this before. And that echolocation that's used in navies make it or allows them to fly. They have eyes, I should say. They have eyes, but they their vision is quite poor. So they rely on their audible sensory perception, and with that the echolocation, and that's how they hunt as well. Now we have utilized that. You might call it, terms like bionics, or you could call it a bionic sensor. We've utilized that echolocation technique of a bat and put that into the sensor. So now it happens the transducer in the sensor that we can see here, that little silver round thing here, that pulses the ultrasonic wave, that then gets reflected by objects in the area, in the vicinity of the sensor, or whatever the sensor is built into, such as an AGV, for example. And then the echoes are then received by the 3 microphones that are here. You can't see them, they're very tiny, but yeah, they're just about here. And then these echoes that are received from the microphones, by the microphones here, are then sort of used, depending on what echo, what the arrival time is, so the typical time of flight measurement. So you have the arrival time of an object that is located, so say for example this one here has different arrival times than that one, and based on these arrival times, the origins of these echoes are calculated then as 3D coordinates, and this is what makes the system so special, because usual time of flight sensors, such as the 1D ultrasonic sensors that you have, they only give you the basic time of flight, so basically so the x coordinates, so how far is an object away. But with our very own unique sensor setup, you get 3D coordinates. So you don't just get the distance from an object, but you also get the height and relative to the sensor, obviously, and whether it's to the left or to the right of the sensor, relative to sensor positioning. So you have the X, Y, Z coordinates. And that is what we call our turnkey 3D collision avoidance system. So with the system that you get with us, you get the sensor that you just showed, and then you get the collision avoidance software, which is housed in this Toposens processing unit here. And that obviously makes for very safe operations on top of your other sensors that you may have built into your system already anyway. Now, just a few key specs that are very important to note. The detection range we have is from anything from near field up to 3 meter. So this is normally with a 75 millimeter pole detection. So we have like this reference standard case. And then we have the field of view is in the near field, because this is important to note that we offer here a sensing solution that is very good for the near field, which is very important in collision avoidance. So you cover that space right in front of the sensor, right in front of your AGV or mobile robot, whatever you have. And at that close distance, right in front of the sensor, you get a coverage of up to 160 degrees. So that's a very large opening angle. And as you go further away, as you get closer to the 3 meter of a detection range, it reduces to up to 110 degrees. And this is purely, and you can see it, I'm going to show you a video in a minute. And on that video, you can see the opening angle based on the physics of ultrasound, the ultrasound wave. Now, the detection capability is, so with that, what's meant with that is what is the smallest object that can theoretically be detected? And that is 2 square centimeters. And that, which is also important to note, is when it can literally be lying on the floor as well. So a lot of other sensors have difficulties, depending, and this is obviously also due to sort of physics behind it, but they have problems when objects are lying on the floor and are very small, difficult to detect because it might be a glass or a piece of glass that could be lying around because something broke in the factory, etc. And this is where it's good at. Now, this system, as I've just mentioned here, the processing unit, is very, very easy to use as well, because you get with it a graphical user interface. So you have that GUI here. And in that GUI, just quickly go over that. And obviously, if you want more information at any point, any point of the technology, then you can obviously see us at Logimat, but I'll get to this in a minute, or drop us a message or give us a call. But just to guide you through this quickly, so you have here the region monitor view where you can set your regions. And important to note is we have 2 zones. So we have a warning and a stopping zone. The importance with that is that anything that's detected in the stopping zone, the system, our collision avoidance system, will trigger an input to the mobile robot to slow down. Anything that's detected in the inner zone, which is a very important zone, which is the zone just in front of the sensor, triggers a stop command. So here you have a warning command, and here you have a stop command. And these are where you can set the zones. So these 2 zones are dynamic zones and freely adjustable, up to a maximum of 3 meters, as I've just said before. And you can also adjust the height. So depending on where your sensor is set on the mobile robot, you have here your different height positions and the length. And you can also, this is like a top-down view, bird's eye view, you also have your width that you can set. Now you have your different filter settings that you can set depending on use case and what you want to get out of it. And you also have these all different settings, such as, as I said here, the length and the width and the height and the offset and orientation, etc. You can also set where your sensor is positioned relatively to the AGV. And with that then, without further going further into detail, that you then use to sort of serve your mobile robot from the collision avoidance system. So here you see points, and you get 3D view as well on here. If you tick that, can't tick it now because obviously it's just a screenshot in the presentation. But yeah, you can tick that, you get full 3D view, just as the sensor would see, and then you can sort of move this about a little bit, just as you wanted to. But this is just for obviously illustration purposes. And then this shows you what the system does and how it works. Now, this just a little video just in between the slides, just to show you what exactly happens. So this is a little AGV, the top load, and here you have these zones. Here you have the stopping zone, the warning zone, and you can see now, I'm just going to pause this. You can see now these forklift forks are detected. So this is what how it works in principle. They're detected in the stopping zone here, the outer zone, and then also now detected in the stopping zone. So the AGV is already started slowing down, and now it is actually stopping. Now, obviously, once that object, the hazard as such, is removed, the sensor then, or should I say the system, triggers a basically an off signal. So now the zones are not violet anymore. So it's on off. It's IO basically signal. So zones are not violated anymore. The coast is clear, so to say, and the AGV then moves on again. And here we have the same with pallets, for example, when that happens. So that makes the AGV slow down and stop. And then once the coast is clear, it'll move on again. Now, just go in a little bit over the advantages that our system has and offers compared to other sensor systems. Now, as I've said before, as in terms of 3D collision avoidance, you have the problem of reliable detection performance. Now, with this system, due to the physics and the sophisticated algorithms behind it, we can see small and difficult to see objects very well. Then the problem, as I said in the beginning of my presentation, that especially optical sensors, although they work really well in other situations, but when the environmental conditions are not favorable, such as, like I say, lack of light, for example, then they have great difficulties detecting certain objects where sound-based sensing is practically immune to that, because obviously this is just nature of physics. Yeah, so a sound travels through anything, gets bounced off anything regardless of any light or non-existent light. And so a lot of these sensors also have reasonably big blind zones, and ours has got virtually no blind zone. So with that, not just that, but it has this ultra wide field of view. And important to notice here is obviously detection of objects on the floor or close to the floor as well, which is very, very important when trying to make a system safer and have less false positives or false negatives as well, which obviously then in turn means that you have a system that has potentially more collisions and potentially reduces your return of invest as well because of these collisions that can happen. Now, in terms of ultrasound and ultrasonic sensing technology that's already out there in the market, which is standard 1D typically, because like I say, ours is the world's first only 3D. So all the others are tend to be like 1D, and the problem with 1D is that you get a very low resolution and you only have that, as I said, just in the beginning, you have that typical just the time of flight. So you don't get the Y and Z coordinates with it. Now with us, we have this high resolution spatial data, and so it's not you can't compare it to sort of the LiDAR output. And we are competitively priced compared to a lot of more expensive sensor solutions, and that's just due to the hardware as well and the way it's set up. Now what I've told you now about sort of the advantages, they can very easily be whittled down to 3 key benefits of our USBs. And the first one, as I've just said, is we look at this terms of detecting the undetectable. So where, like I said, where other sensor systems have difficulties detecting, we can detect these sort of undetectable objects. And we offer that full coverage that I've just said. And we have that navigation in difficult surroundings. And the short sensing that I've said just before, from the 20 centimeters on, is basically a huge benefit that any sort of really reliable, safe AGV or AGV system should have anyway. And that in turn gives you this really good sort of yeah, customer value that you can convey to your customers then is that you can have a improved satisfaction because your AGVs are equipped with these sensors and other sensors, optical sensors. You should always have a 2D safety LiDAR anyway with it, but that just gives it sort of rounds off your perfect mobile robot sensing solution. It saves you money and reduces accidents. I've already covered that. And that obviously with that you can grow your business. So basically that is what it's all about in a nutshell. Let's not forget in this webinar we're not going to go too much into the finite details of it all. But if you have any questions, then always get in touch with us anyway or see us at Logimap. But yeah, that's basically what you get with our system. So you get that sensor, you get a processor unit, and it's also worth noting that it can be used as a standalone system. So you get the I/O ports that signal you the zone violations. So either zone's violation is on, when a zone is violated, when something is detected in the warning or stopping zone, or you get the on, so the off. So the coast is clear again, as I said just before, if an object has been removed or another AGV has crossed the path successfully and is out of the way. Or you can use it in a sensor fusion version, and then a pre-processed point cloud is accessible via Ethernet. You can also use this system as a retrofit if you've already got your AGV system, and you've already got LiDARs incorporated or cameras, whatever you may have in it, and you just want to add this extra layer of safety to it with an ultrasonic sensor, and so you can use it as a retrofit. You can also have that design-in version if you start from scratch again, new, and you can sort of put it all together and use it like that. Now, if you're interested in using that 3D ultrasonic collision avoidance system, ECHO ONE, and you want to sort of trial it, have an in-depth assessment, then we are also always very happy to offer you a proof of concept, and sort of in a one-day sort of situation where we offer support as well, and that going up to full pilots as well. You can buy the system offers, you can talk to us at Logimat about it, what your sort of individual requirement is and what you would need from us, and we'll just take it from there. Now, I'll just show you another video now quickly that will nicely put everything I've said into a sort of a visually pleasing video. And this is now, I'm just going to pause this because, as I said to you at the start of the presentation, this is how the physics work, and I always find it's much better to visualize it like that than to just get told about it. So here you can see the reflections coming back that bounces off objects in the vicinity of a sensor, and then you get these two dots. Now here you have the point cloud, and then you have the points. And here you have these USPs that we always say we offer with our system. I think it's more or less self-explanatory after everything I've said. As I said, low calibration effort, it's easy to integrate. We are fully IP67, and which means also that the sensor can also be used outdoors. Yeah, so rain, it doesn't matter, sunshine. As I said, the physics behind it of ultrasound mean that it just works anywhere, regardless of what the conditions are. It can detect multiple objects up to usually around 25 in that zone. And then obviously we covered these bits. Now, that is the ECHO ONE sensor. This is what we've already seen, so we can just skip that. But then again, it's a very short section anyway, so let's just have a look at that again. You can see what happens when the 2D sensor systems only scan in one plane. Now, this is what 3D scanning looks like. So you have these 3D warning and stopping zones. So once they're activated, the system slows down or stops, depending on the zone. So just as a reminder, violation of the warning zone, the outer zone, which is yellow here, means slowing down. The violation of the more crucial inner stopping zone means the system stops, comes to a halt. Yeah, I think we can probably just skip that. This basically is what happens when, so here you have so this is a mixed operation. Here you have a manned forklift, still gets detected by that little AGV down here with the sensor on, stops, and then it moves off once that's out of the way. Now, on here you can see what exactly happens when objects are detected, such as these forklift forks. You have that wave bouncing off, coming back, being received by the microphones on the sensor. And then you get these two coordinates here. Yeah, once that moves out of the way, the coast is clear again, it's green, and the system moves on. And this is quite a nice illustration of what happens when, I'll just come up to it in a minute. This is the sensor you have here. And this is how it gets integrated into an AGV or AMR or any other mobile robot. And then the USBs we've covered. We all know them now. This is the Toposens processing unit. Let's pause that for a minute. So you have the unit here attached to the sensor, acting as a gateway, and you have obviously it houses the noise filters, which I said previously, it's a very crucial part of the overall system that makes it so special. It's very sophisticated. And you can have you set your parameters. As you remember, I showed you in the GUI how you set the parameters. You also have the warning and stopping zones in there. And let's move on. So this is the all-important field of view. So if you remember, I told you that I was going to show you the field of view in the video. So this is what it looks like. And here you have, in front of the sensor, you have that massive opening angle, that field of view. And then that just reduces, and this is literally down to the physics of ultrasound, that reduces as you get away from the sensor. So in that 3 meters coverage, it sort of gets smaller, like as you can see. And this is why it's also important to note that this solution is most effective in the near field sensing, which is the crucial bit for collision avoidance anyway. And here you can see the warning and stopping zones and how they're fully configurable depending on how you want to use it, but whereabouts on the AGV or on your mobile robot the sensor is positioned. So depending on here, you can see it's very close to the ground anyway, so you have your sort of reduced zones. But yeah, depending on what you want to use, how you want to use it, you can fully position, fully set these zones. And then just showing you the benefits that I've covered already anyway. And then you can just see the GUI. Okay, we've had that bit, let's just skip that. But it's quite interesting to see as well how the zones are set. And then here you have that 3D view. And this is what it looks like, again, when the collision avoidance functionality is in full operation. But we've seen that, so we're going to skip that. This is an important thing to notice as well, because these are very small objects on the floor and they get detected as well, just like that. And that's just about it. I'm just going to fast forward this a little bit. And let's get to the, oops, just jumping ahead here, to our last slide. And that is basically to let you know that we are at Logimat, as you know by now. We are located this year at the entrance east, so literally in that big open foyer. And the booth is hence got the number EO, so EO is the the entrance Ost, East 91A. So this is where you can find us. This is what our booth looked like last year. So do come and see us, drop by, have a coffee with us and a chat and see live demos as well. We have, just like last year we had a demo, we're going to have another demo again this year. And we are looking very much forward to seeing you at LogiMat and talk to you about your individual needs and your application, your requirements.